right, good morning, AFM students. Today we are talking about the first section in Chapter 5. So in your book, we're going to be on page 311. And I want to point out a couple of things to you before you start your assignment for today. First of all, this chapter is on polynomials. And so a quick reminder about the degree of polynomials. You know that if you do not have a variable at all, like this first example here, it's just a constant, so it has a degree of 0. When x is to the first power, that's first degree, which is linear. When it's x squared, that's quadratic, that's second degree. If the highest exponent is x cubed, that would be a third degree. And the solution is going to match the number on the degree. So if you have a quadratic equation, there should be 2 solutions. A cubic equation, there should be 3 solutions. This isn't the first time that we've talked about this, but I do want you to look for just a moment at the graphs. This is figure 2 on the next page. Notice that when you have a linear equation, there's only one x-intercept. Quadratic equation, you have, really this is a double root here, but it's like 2 solutions. Cubic equations, quartic equations, quintic equations. I want you to pay attention to the end behavior. Notice that for the linear, the first degree, the third degree, and the 5th degree, anytime your degree is an odd number, notice that the end behavior of your graph is going in opposite directions. In this example here, as x moves to the left, the y's are going down. As x moves to the right, the y's are going up. The same thing with cubic. As x moves left, the y's move down. As x moves right, the y's move up. And the same thing with here. Anytime you have an odd degree like this, the end behavior is going in opposite directions. Now notice the 2 that are even. When it's a quadratic equation, the end behavior is going in the same direction. The same thing with quartic, the same thing with the 6th degree or 8th degree or any other even degree. So when we start talking about end behavior, you can tell the direction that the ends of the graphs are going to go just based on the degree. If you look at example number 1, this first one here is a cubic equation. Now because it's cubic, that is an odd, the end behavior should be going in opposite directions. But hopefully you remember what the negative out in front does. We talked about that in the previous unit when we did transformations. The negative out in front is going to reflect the graph over the x-axis. So when you look at the solution that matches this equation, is here. The end behavior is still in opposite directions, but it has been reflected over the x-axis. If you also notice in example 1b, now this one is quartic. All of this stuff is being raised to the 4th power, so essentially you have a quartic equation. There is no negative out in the front, so this one is not going to reflect, and when you look at the graph, the end behavior is going in the exact same direction because it's an x to the 4th power, which is an even number. And then finally in example number 1c, this is a quintic equation. It is an x to the 5th power, but there is a negative out in front, so it's going to get reflected, but because it's an odd degree, the end behavior should be going in opposite directions, and you can see that that's exactly what happened over here. End behavior is going in opposite directions because it's odd, but it did get reflected because of that negative. So I've got some stuff over here that I just want you to look at. This is the way that we would write this. For this linear equation, I've got that as x goes to negative infinity, that means as x moves to the left, that y is going to negative infinity because y is coming down. As x goes to infinity, toward the right, then y is going toward infinity because it's going up. Now, if I had a negative out in front, then that whole thing would flip. Now you can see that as x goes to negative infinity, the y is going up. As x goes to infinity, the y is going down. The easiest way to kind of look at this is with the x. When you're talking about x going toward negative infinity, you're talking about it going to the left. As x goes to infinity, you're talking about it going to the right. So you just have to look, is the graph going up or down as x moves to the left or right? Here's a quadratic equation. Notice that as x moves toward negative infinity, as x moves to the left, the graph is going up. It's going toward infinity. As x moves to the right, as x goes toward infinity, the y is going toward infinity. This is when the end behavior is in the same direction. Now, if that reflected over the x-axis, this is what it would look like. As x goes toward negative infinity, the y is going down toward negative infinity. As x gets closer to infinity, as it goes to the right, the y is going to negative infinity. Okay? Now I want you to jump ahead to example number 3. Now in the book, example number 3 is actually solved incorrectly in the book. So I have the correct one right here on my paper. And I want you to remember that solutions, x-intercepts, zeros, roots, they're all the exact same thing. So when you're looking for the solutions, you're really looking at the x-intercepts. So notice in this graph, we start out with this cubic equation. Before I do anything with my graph, the fact that this is cubic means the end behavior is going in opposite directions, and I should have 3 solutions here. So when I start to solve this, I'm solving by factoring. Since the solutions are the same thing as the x-intercepts, we just let y be 0. The first thing we look for when we factor is a GCF. So I've pulled that x out front. All of this quadratic equation is left over, and then I factored it. You set your factors equal to 0, and my solutions should be 0, 2, and 3. So when I do a rough sketch on my graph, and this doesn't have to be perfect, I don't want you to stress out about the maxes and the mins right now. We just want to focus on our solutions. But 0, 2, and 3 should be my solutions here to this cubic equation. And because I know the end behavior is going in opposite directions, there is no negative that's going to flip this thing over, so you can see that your sketch should look something like this. As x moves to the left toward negative infinity, the y's are going down. As x moves to the right toward infinity, the y's are going up. So that's how your end behavior should look like. So on your homework tonight, some of the problems are already in factored form for you. Some of them you may have to factor first. Okay, we're going to look at one more example, and that's example number 4. Okay, so this one I see we have a quartic equation. Now because this is even, end behavior should be the same direction, but notice there's a negative out front. So if the same direction has been reflected, I'm expecting my final result here for both of these end behaviors to be going down toward negative infinity. So we are going to factor out a negative and the x cubed that all of these have in common. Once I factored that out, I've got this left over, and then I factor further. Now right here, technically we have a double root because x squared is like x times x. So it's like you have the solution of 0 used twice. This solution is negative 3/2. This solution is a positive 1. So on my graph, I've got my negative 3/2, halfway between negative 1 and negative 2, my 0 and my 1, and I'm just going to do a rough sketch. Now, I want you to notice we already knew end behavior should be going the same direction. So when you do your sketch, as you come up through that negative 3/2, you cannot come down through the 0 because then they would be going in opposite directions. Because of that double root right there, it's almost as if you're going in and back out again to show that there's a double root right there at 0. So your solutions are at the negative 3/2, a double root in and back out again at 0, and then you come back down through the positive 1. The end behavior matches what we expected. The negative reflects it, and they're both going down toward negative infinity. As x moves to the left, you're going toward negative infinity. As x moves to the right, you're also going toward negative infinity. And that is it for today. Just this quick little reminder about end behavior, a little bit of review of factoring and solving. Okay? If you have any questions, please don't hesitate to email me. You can call, and I can help you in any way I can. Good luck.